Hi class, I am on page 150. It's the last page of your year 1 notes. Differentiating trig functions from first principles. And it's got an example here. Prove from first principles that the derivative of sine x is cos x. So they're saying when you differentiate sine x, prove that you get cos x. Some things that you have to go back to. So for this topic, you need to know something. So you need to know. So go back to your notes on page 105. I'm just going to flip back. Page 105. I'm just going to find it. Mine's empty, but yours should be filled in. Page 105 is the small angle approximations. And when theta is small, then sine theta is approximately theta, tan theta is approximately theta, and cos theta is approximately 1 minus theta squared over 2. So you're going to need to know these facts. And what I've done is I've just put them on page 150. To be honest, I could have just put sine of h over is approximately h, because I'm going to be using h. So sine of h is approximately h. Cos of h is approximately 1 minus a half h squared. Okay. And then they'll give you this extra information. It doesn't do it in this example, but if this came up on an exam paper, they generally give you this extra information here. So here, they're saying that sine h over h is approximately, it approaches 1 as h tends towards 0. So here, that should make sense to you, because if h is getting smaller and smaller and smaller, closer and closer to 0, then your small angle approximation becomes more accurate. So sine h, this top bit, becomes h. So you've got h over h, which is getting closer to 1. And the other one that they should give you is cos h minus 1 over h. So cos h is this bit here, 1 minus a half h squared. Take 1, that's that bit there, over h. If I just tidy that up, I'll get minus a half h. And if I'm taking the limit as h tends to 0, well, if h gets closer and closer to 0, you'd expect this whole thing to be approaching 0. Okay, so this bit here they would give to you. Okay, so you wouldn't have to worry about it. They would give you this bit here, that sine h over h is 1 and cos h minus 1 over h is 0. Okay, I was just trying to explain it to you over here. Right, so let's do the proof from first principles. So from first principles, it means that you've got to use that formula, which is given in the formula booklet, that f dashed x equals the limit as h tends to 0, f of x plus h minus f of x all over h. Okay, and then I have got, I've just got my online textbook open here as well. If you want to refer to it, it's page 232 of the online textbook. So here, if f of x is sine x, then this bit here will be sine of x plus h. So I'm just going to write equals the limit as h tends to 0 of sine of x plus h minus sine of x all over h. And here you should be able to see that this is an addition formula that I can use here. So I'm going to use the addition formula for sine. So the limit as h tends to 0. So this bit here will become sine x cos h plus cos x sine h. So that corresponds with this bit here. Still got my minus sine x, that's that bit there. Still got my divided by h there. And then I'm going to collect together all my common terms. So I've got sine x and sine x there. So I'm going to put them together. So equals the limit as h tends to 0. So I have got sine x cos h minus sine x plus cos x sine h. Okay, divided by h. So what I'm going to do is I'm going to divide this bit by h like that. And this bit I'm going to factorize actually. I'll do it in a second. So equals the limit as h tends to 0. And I've got a common factor of sine x. So I'm going to take that out. And then I have got cos h minus 1. Cos h minus 1 all over h plus cos x times sine h over h. And then they've told us that cos h minus 1 over h, cos h minus 1 over h be 0. And they've told us that sine h over h is 1. Okay, so what I'm going to do is I'm going to put that in. So I'm going to say, so f dashed x equals sine x times 0 plus cos x times 1, okay, which equals cos x. So the derivative of sine x, so when f of x is sine x, f dashed x is cos x. Okay, so the next one is exactly the same, all right? It's exactly the same. You're going to get a cos h minus 1. You are going to get a sine h over h, most likely. And you just follow the same steps. Now, if this comes up in an exam paper, it tends to be about 5 marks. It's very much algebraic manipulation that you're doing here. It might look a bit daunting at the moment, but actually, if you just follow the steps, it's not hard at all. Okay, I'm going to do this one with you, and then I'm going to set you some work for that you can have a go at. And it might be that I might just say, do that again without looking at my notes, do that again without looking at my notes. Okay, so let's do this one. So here I'm going to let f of x be cos x. And I'm going to use that formula again. F dashed x is the limit as h tends to 0. F x plus h minus f of x all over h equals the limit h tends to 0 cos of x plus h minus cos x all over h. And then I'm going to just use my addition formula for cos equals the limit as h tends to 0 cos x cos h minus sine x sine h minus cos x all over h. I am going to collect my like terms. So I've got cos x there and I've got cos x there. So I'm going to put them together. Equals the limit as h tends to 0 cos x cos h minus cos x minus sine x sine h all over h. I'm going to factorize that bit. So you might want to pause this if you think I'm going too fast. So here I've got cos x, common factor. So I've got cos h minus 1 over h. And here I've got minus sine x with a sine h over here. And again, this bit here is 0. And this bit here is 1. So I can say it equals f dash x equals cos x times 0 minus sine x times 1, which equals minus sine x. So therefore, when f of x equals cos x, f dashed x is minus sine x. Okay, and that is the year 1 text notes done. Now, on the last few pages, you have got a glossary with identities, rules, things that you can use, okay? But we have finished this. That doesn't mean I finished teaching you. I will still be teaching you. We will be doing some year 2 stuff. We are a little bit ahead of where we would have been. That's good. So we're gonna. I am going to be doing more work. But we have got an exam coming up soon. But I will tell you more about that later. Okay.